Welcome back to our intermediate algebra course, and today we will cover section 6.4, dividing polynomials. Since we are working with rational expressions, with fractions, the puzzle is about it. Move only one matchstick to fix the equation. I like these puzzles because usually you can find more than one way, more than one answer. Look, 5 minus 4 over 6 minus 3. 5 minus 4 is 1, 6 minus 3 is 3, 1 over 3 is not equals to 9. So something is wrong. You have to move just one matchstick to fix this equation. Take from one place, move to a different place, and try to fix the equation. Okay, we will check the answer later. And we are working in dividing polynomials. Basically, we have two methods. We're going to focus on the long division, but I will show briefly the syntactic division as well. But first, let's check a very simple case that we can simplify a fraction to work out the division. So dividing a polynomial by a monomial. This is a very simple case. You can use long division in this case, but there's a simpler way. I'm going to show you an example. Look at this. Negative 12a cubed plus 36a minus 15 on the numerator. And the denominator, to use this method, we need to have just one term in the denominator, a monomial on the denominator. We have 3a, so great, we can use this method. What we're going to do is just break this fraction into three fractions with the same denominator. Look, right down here, 3a, 3a, 3a. So all the fractions will have the same denominator. On the first one, we're going to use the first term, negative 12a cubed plus positive 36a plus negative 15. Okay, so you have all the terms, and you can remember the rule for adding fractions with the same denominator. If you add, you go back to this fraction here. And now we will check each one for simplifications that we can work. For example, we can divide negative 12 by 3. Negative 12 divided by 3 is negative 4. And we can divide a3 by a. Remember rule of exponents. This is going to be, don't forget, we have an invisible 1 here. An invisible 1 as the power. When we don't have any power, we can say there is an invisible 1. So 3 minus 1, 2. The next fraction plus 36 divided by 3, 12. a1 divided by a1, cancel out. Positive and negative, negative. 15 divided by 3, 5. And we still have this a on the denominator over a. That's going to be the final answer. Okay, but we only can use this method, remember, if we have division by a monomial. We need to have just one term on the denominator. Let's move. You can try this example by yourselves. See, again, we have to split into three fractions with the same denominator. And the first fraction, we have 10 t4 as the numerator, negative 35 t3, and positive 5t squared. Now simplify, and you're going to find the answer. You can try by yourselves. Now let's work division of any polynomial by any polynomial. Then we need to use one of these two methods. Long division Yeah, actually the syntactic division is a special method you cannot use for any polynomials. But long division you can basically use for division of any polynomial by any polynomial. Doesn't matter if it's a trinomial, binomial. Think about dividing numbers. Okay, this is just a revision on how to divide numbers. Let's review how to divide numbers. And 7,256 divided by 43. We're going to get 72 divided by 43. The answer will be 1. And now, okay, we divided, we got 1. Now we multiply 1 times 43, 43, and we subtract from 72. 72 minus 43, 12 minus 3, 9, 6 minus 4, 2. Great. Now bring down 5. And you're going to repeat the same steps, right? Divide 295 by 43. And maybe 5 is going to be 215. No, we can do 6. 6 and is going to be 258. Now subtract, right? Divide, multiply, subtract, and then you have 15 minus 8, 7, 8 minus 5, 3, 37. Okay, that's what we will do. Bring down 6 and then divide again. 376 divided by 43, maybe 7, maybe 8. So let's try 8. 8 times 3, 24. 8 times 4, 32. Okay, 6 minus 4, 2, 7 minus 4, 3, 0. And that's going to be the... We don't have anything else to bring down, right? 6 was the last one we brought down, and this is the remainder. We will use this same method. This is just to understand that we will use those steps as well when we are working with long division of polynomials. Let's look this example. 28x squared minus 23x minus 15 divided by 7x plus 3. It looks scary, but no, let's do it step by step. First, you get this first term, 28x squared, and you're going to divide by 7x, only 7x. 28 divided by 7 is 4. X squared divided by x is x. Okay? Now, you did this. Now what we will do is multiply 4x. Now we're going to multiply by both. Multiply 4x by both of the terms in the divisor. 4x times 7x, 28x squared. And 4x times 3 is 12x. And subtract. Subtract. Remember, we need to subtract this whole thing. And I will do something here because I don't want to make mistakes. When I'm subtracting, I will change the sign. So this is positive 28 becomes a negative 28. This is positive 12 becomes a negative 12. Okay, so cancel out. And negative 23x minus 12x, negative 35x. Bring down negative 15. Divide negative 35x by just the first term, 7x. What's going to be? 35 divided by 7, or negative 35 divided by 7, negative 5. x divided by x cancel out. And next step, multiply, but multiply by all terms in the divisor, both terms. Negative 5 times positive 7x, negative 35x. Negative 5 times positive 3, negative 15. Subtract. When we subtract, we change all signs. Okay, subtract. And we'll cancel. 0 is going to be the remainder. The final answer for x minus 5. Not all the times we're going to have 0 as the remainder. Okay, this case we got 0, but not all times we have this situation. Maybe another example. Let's see. All right, let's try this one. 4x squared minus 6x plus 8 divided by 2x plus 7. Again, get the first term and divide by only the first term in the divisor. 4 divided by 2 is 2. X squared divided by x, x. Nice. Now, multiplication. Multiply these quotients, these results, to x times both, or all terms in the divisor. 2x times 2x, 4x squared, and 2x times 7, 14x. Subtract, and this will become minus, okay? Let me even erase the plus, becomes a minus. Cool. Cancel. Negative 6x minus 14x, negative 20x. Divide by the first negative 20x. Bring down the positive 8 plus 8. Divide the first term, negative 20x, by 2x. That's negative 10, right? Negative 10 times 2x, negative 20x. Negative 10 times positive 7, negative 70. Don't forget, this is very important. Don't forget to subtract. When you subtract, you change all signs. This will cancel out. And 8 plus 70, 78. That's the remainder. We don't have anything else to bring down. That's going to be the remainder. One interesting thing. We write our final answer as, okay, this is the final answer, 2x minus 10. And we still have the remainder. So let's write down here the remainder is a positive 78. And keep the divisor 2x plus 7 under the remainder as a fraction. Okay, this is how we will represent the final answer. Okay, this is the quotient we just found here, and this is the remainder over divisor. All right, that one will be kind of a practice at home. How we divide c squared plus 3c minus 2 over c plus 1. First, you have to remember that fractions are divisions, and you can write this as a long division. C plus 1 is the divisor, and c squared plus 3c minus 2 is the dividend, and now we find the quotient. Okay, use the same step by step and check if you have any remainders. That's what you will find at the end. This is going to be the final answer, so you can check. All right. Another one that you can practice at home. Look, let me tell you something about this question. If the question asks you, show this division as a long division, then you have to show all those steps, right? All this step by step, divide, multiply, subtract, bring down, divide, multiply, subtract, bring down. But if you look carefully at this question, you can find the answer beforehand, just to compare, because we can factor out y squared minus 5y plus 6. Look, two numbers that multiplied is 6, and if you add is negative 5. Using the guessing method, you can think about 6 times 1 is 6, 2 times 3 is 6. All right, maybe we can combine 2 and 3. Y minus 2 times y minus 3. Negative 2 plus negative 3, negative 5. Negative 2 times negative 3, positive 6. Okay, we can represent division as a fraction. The divisor is the denominator. And look, cancel, cancel. The answer will be y minus 3. So that's a case that if the question asks you to show long division, then you can write down y minus 2, y squared minus 5y plus 6, and you already know the answer will be y minus 3, right? So you just show the steps, but you can check your answer using the factoring and simplification of fractions. Syntactic division is another method. It's like a step-by-step that you can memorize and will help you solve some specific divisions of polynomials. I'm going to skip this explanation. Let's show the example. Look, let's say we have this, and 3x cubed minus 2x squared plus 5x plus 4 divided by x minus 2. First, when you're using syntactic division, the divisor needs to be x plus something or x minus something, okay? Always. And if we have x minus c, let's say x minus c, forget about the minus, we're going to use c right here. Write down like in your scratch paper, the 2 on this side, and on the left hand side. On the right hand side, you're going to write all the coefficients. All the coefficients, even if you have 0 coefficient, you have to include here as well. Okay, so we have 3, we have negative 2, we have positive 5, and we have 4. Okay, and this method is quite simple. Yeah, you first bring down the 3, and 3 times 2 is 6. You will write down the 6 underneath the next coefficient. Now you combine or add negative 2 plus 6, positive 4. 4 times 2, 8, and you're going to write down the result of the multiplication under the next coefficient. Now combine 5 plus 8, 13. 13 times 2, 26. 26, you're going to write down here underneath the 4, the last coefficient, and you combine 4 plus 26, 30. The answer will be, this is x3, right? So the answer will be 3x2. If this is 3, the answer will be, we will start with x2 plus 4 x plus 13, and the remainder is 30 plus 30 over x minus 2. That is the final answer. It's like it looks like a trick, but it's a kind of a method to find those the answer to those divisions real quick. See, it's something that you have to kind of memorize, remember. It's kind of hard to understand. So I don't like that much the syntactic division, but people that, students that will work with calculus on the future, college algebra, sometimes they have big expressions that they have to simplify and divide, and it might be helpful to use syntactic division. Another kind of rule that is pretty useful is the remainder theorem. Let me explain how it works. Also only works if we are dividing by x minus a number or x plus a number. Okay, you need to have something like polynomial divided by x minus 2 or polynomial divided by x plus 5. And let's say you have this polynomial and we need to fix it because it's not quite right. Okay, this is power of 5. Px equals 4x6 minus 2x25, sorry, x5 plus 35x4 plus 17x squared. First you need to complete because you have power of 6, you have power of 5, power of 4. We don't have power of 3, so we can say 0x3. We have power of 2, and we don't have x1, so 0x plus 0. Okay, we have to complete to have all the powers in a decreasing sequence. Look, 6, 5, 4, 3, 2, 1, 0. Nice. Now we're going to write, this is the syntactic division. If you work out syntactic division, you will find this remainder. Okay? But there's another way of finding the remainder. If you have this kind of division that you can work as a syntactic division, you just plug in. This is divided by x minus 4. Okay? This is a division by x minus 4. Okay? So you're dividing this polynomial here by x minus 4. Get this number here after the negative 4, and you plug in into the polynomial 4 instead of x, 4 minus 25, 4 to the power of 5, plus 35, 4 to the power of 4, plus 17, 4 squared. Now you need your calculator to find the answer. You're going to see that P of 4 equals 16. You need your calculator, okay? I didn't show here the math because it's something that you're going to need your calculator. But yes, I encourage you to check, and you're going to see that that's going to be equals to 16. The same result we find using the syntactic division is the same that you're going to find if we use the long division as well. And that's it about section 6.4 and our challenge. So, could you find a way of fixing this this equation? That's wrong, definitely wrong. 1 over 3 is not equals to 9. As I told you, I like these matchsticks challenges. There are lots and lots of matchstick challenges on the internet, and because they can have many different ways of solving. I'm gonna show you one way, maybe is the easiest way to visualize. You can remove this, okay, remove this. Then you're gonna have a 3 and place as the plus, making a plus sign on the numerator. So 5 plus 4 is a 9, divided by 6 minus 3 is 9 over 3, 9 divided by 3, 3. Now we have the right answer. Thank you for watching, and I hope to see you on the next meeting.